So here we have a buck converter. I will show you how it works and how you can find the ratio between VO and VI. So the first thing I want to do is to look at the circuit when it's on. What happens when it's on? So we just write on. So now the switch is closed. There we go, current through the switch. This means that the diode is reverse biased, and there we go, no current through the diode. So everything would go through the inductor and then into this either the capacitance or the resistance, right? So this would mean that VI equals VL plus VO. Because you can just act as this diode doesn't exist. So this would make sense because there is a voltage difference here, VO, and voltage difference here, VL, right? And you know that VL equals L multiplied by the change of current in the inductor over the change of time. And this can also be written as L multiplied by the change of, it's also the change, but just numerically, right? So what we want to do here is to find the change of current going through the inductor. Because in steady state, we want the current that goes through the inductor here, when it's on, be equal to the change of current in the inductor when it's off. So for example, if the current rises like this when it's on and like this when it's off. So in steady state, this value here should be equal to this value here, which means that the change of current when it's on is equal to minus the change of current when it's off. So we need to find the change of current when it's on to compare it to the change of current when it's off, right? So we just put in this expression. So VI is equal to L, and the change of current over the time, change of time, and plus VO. So delta I is equal to VI minus VO over L multiplied by delta T. So in this case, delta T is equal to dt, where the d is the duty cycle and the t is the period, right? So now we want to find out what happens when it's off. So now this switch is open, which means that the current continues to flow this way because of the inductor. And then it will flow like this, that way, which means that the voltage here, the VL plus VO, is equal to 0. So now we can put in the value for VL. So it's equal to L multiplied by the change of IL, right? And divided by the change of time. And remember that this delta IL, we set that as positive, so when it's rising. So now it needs to be negative because it's falling, the current is falling. So, and this is equal to minus VO because we just moved VO over to the other side, right? So now I want to find the delta IL. It should be equal to plus, now it's plus because it's minus and minus. So it's plus VO, multiplied by 1 minus dt multiplied by the period, which is equal to this here is equal to delta T. And then over L, right? So now we have two expressions for a delta IL, which will be equal, right? And this is T off, yeah. There's a difference. So I can just write it here, T off. And if we set those equal to each other, we will get an expression. So VO, 1 minus D multiplied by T, and then divided by L, is equal to VI minus VO over L multiplied by dt. So what you see here is that we can cancel the period with a period and L with a L. So that leaves us with VO 1 minus D is equal to VI minus VO. I forgot to multiply by D. So if we move VO over, we would get that VO. And then it is minus D plus D. So those cancel each other out like this. And it equals VI multiplied by D, of course. So this would mean that VO over VI is equal to D. So that means that the ratio between VO and VI is equal to D, the duty cycle, not this diode here.